it can get bigger. Now, we are pretty close here to Michigan's Adventure. I know there's some roller coasters there. If we look at this as a roller coaster, and if we say this is the ground, at what point would the roller coaster car have the most potential energy?
Energy due to position.
Energy due to position. At the top of the hill or the bottom of the hill?
Potential energy.
Okay, we've learned this before. We talked about this in probably middle school science class where we talked about potential energy and how it gets transferred. We're going back to this idea of the energy of position. What does that mean? Why does it have the most energy due to position? Well, if you look at the height, the distance of x is significantly bigger than the distance of y. The distance between, in this case for gravitational potential energy, the position between the Earth and another place up in space, not space. The greater that distance, that would be pretty awesome. The greater the distance, the more energy due to position we have. So what is happening to the energy? Okay.
Why? What is it about the roller coaster car that means that at the top of the hill there's more energy due to its position than at the bottom of the hill?
Well, I actually have a question. If that's like where it's potentially energy, where does that become like real energy?
No, that's
You said
why I said
potential
energy
energy.
due to position. Let's completely ignore the fact that the word potential ever got mentioned. It's energy due to position. What else is involved when we say the distance of the car with respect to what? The earth, right? The ground, the earth. So the car and the earth, it takes energy to keep it off the ground because there's an interaction between the ground and the car. What is that interaction?
Gravity.
Right, and which basically just says that the ground and the car are actually attracted to each other, I would say. Not wanting to come together, they're attracted to each other. So if you have two objects that are attracted to each other, and you want to put distance between them,
Like a spring, you have to put in energy.
you have to put in energy to keep apart two things that are attracted to each other. Does that make sense with respect to the roller coaster car? Why we would say it has more energy due to its position when it's at the top as opposed to at the bottom?
It's like tall people have a long way to fall and they trip.
Sure,
So,
which,
yeah.
yeah.
That's a larger.
It's a larger, okay, sorry.
No, you're good. So let's go back and kind of put this all together. If we know that we're still adding energy at this point where the graph is flat, but the temperature is not going up, what can we say now for sure? Where can we say now for sure we are not adding energy? To which of our storage accounts, thermal or phase? If the temperature is not going up, where's the energy not going?
Thermal.
It can't be going to thermal because we don't see an increase in temperature. So what must that mean we are adding energy to? The energy is being now stored in which account? In the phase energy, we're now talking about the position of the particles. So what must be happening to the position of the particles as the energy is still being added?
We're having to use energy further.
They must be getting farther apart. Okay, so then what about this next section? It all melts. Now we're at a liquid state. Temperature goes back up again. Are we continuing to add energy from this point to this point? Absolutely. We haven't changed, right? Time hasn't been suspended. So where is the energy being added to here? Back to thermal.
Is that both?
Aren't they still getting further apart?
That's a really good question. What do we know about particles when we warm them up? We learned this in the last unit. They,
Because they move faster.
like, how does a thermometer work? Why does a
Oh, it
thermometer work?
expands.
They do, and like a thermometer works because as you warm something up, it expands. So that's a valid point, is that, do we have evidence that energy is going into the thermal account? Because temperature is changing, so the particles are certainly getting faster. Are they getting further apart? A little bit they are, but that distance compared to a change of state distance, what do you, with most substances,
Yeah.
maybe not the one we're studying right in this moment.
Yeah, that's where I'm going.
With most substances, what do we know about, in general, the density of solids, liquids, gases? Solids are more dense, liquids are in the middle, and then gases, as opposed to the idea of thermal expansion. So we're talking about this as if one happens at a time.